Page 114. We are going to look at composition of trig functions. We have done trig functions and found their values. We have looked at the reciprocals. We have graphed all of that. We've done the inverses. So now this is a composition, meaning putting more than one thing together, of the trig functions and their inverses. Okay, and we've done inverses for different functions. Y'all have done those before, right? So this first part says recall, which means something you've known before, about inverses. So if I write, I want f of the f inverse of x. So if I take the inverse of something and then I do the function, what would I get out of that? Will be the function of the function inverse of x. X, right? And if I have the function inverse of the function of x, what's that going to give me? X, right? Make sense? And that works, but not all of the time, because there are words that go with this too that are very important for us to pay attention to. It says given function f and its inverse f inverse, if x is in the domain of both functions, then. So the only way that this works is if x is in the domain of both functions, which doesn't always happen. And I mean, it's possible that both functions, you have a domain of all real numbers, but we know that even though the domain of sine and cosine is all real numbers, sine and cosine inverse, is their domain all real numbers? No, it is very restricted, right? And so x is not in both of those. It's possible that x could not be in both of those domains. If it is, then these little rules work. If it isn't, then we have to do it a different way, okay? So with these rules, which looks like all these rules you have to know, you don't really, this will all make sense as like one big thing. But it says if blank, then sine inverse of the sine of x equals x, which is basically saying these things up here, right? And then if sine inverse of the sine of x equals x. So I want you to think about x in both of these cases, okay? In this case and in this case. In one of the two, x represents an angle, and the other one, x represents a ratio or a trig value. So think about in which case x would be an angle, and in which case, which set, like either in this set or in this set, which would x be an angle and which would x be the ratio or the trig value itself. So just think for a second. So in the first set, what do you think x is? An angle or a ratio? Well, the first set is x would either be an angle or a ratio. What do you take the inverse of? A ratio, right? You have to take the inverse of a ratio to get the angle, right? So you take the inverse of a ratio, you get an angle, then you would take the sine, cosine, or tangent of the angle, and then you get the ratio. And so x is a ratio here and here. Does that make sense? Because that's what you're going to take the inverse of. So over here, x has to be the what? The angle, because you would take the sine, cosine, or tangent of an angle, and then get a ratio. Then you take the inverse of the ratio, and the inverse always gives you the angle. So x represents something different depending on which direction you're going. Does that make sense? All right, so if it represents a ratio here in the first set. For sine inverse, what can x not be bigger than for me to be able to take the inverse? What can the ratio not be bigger than? When you take an inverse of a ratio to get an angle measure, right? Because our angle measures can be anything with those pies. Look at your graphs. What's the biggest ratio you could possibly have that works? No, that's not a ratio, guys. That's an angle. Those are angles. You're giving me angles. I'm not asking for the answer part of that. I'm asking, when you take the sine inverse of a number, that number gives you an angle, right? So what is the biggest that your ratio can be? You know the answer to this. Look at that. 1. Don't give me the angles. The biggest ratio you can get is 1, right? Square root of 2 over 2 is a ratio. Square root of 3 over 1 is the biggest one you can get, yes? So what is the smallest one you can get? -1. Look at your range over there. Oh my gosh, right? -1 to 1, right? That's where all of those ratios live within there. With sine and cosine, you can't have anything bigger than 1 because your hypotenuse is always biggest, right? Okay, so that means here, if x is between -1 and 1, then the sine of the sine inverse of x is x. But the x that you're using has to fall within that. if, and the same thing goes for cosine, right? -1 is less than or equal to x, which is less than or equal to 1. So that's your range of your sine and cosine functions. What is the range of the tangent function -1 to 1? What is it? -infinity to infinity. Do I include those? No, because we never include infinities. Okay. All right, so then let's look over here. The sine inverse of the sine of x. When you take the sine inverse, think about what your range for the sine inverse function is. All of your answers, when you take sine inverse, have to fall between what and what? No. -pi-halves and pi-halves. That's the range. Because for sine inverse, the range, the y values are the angles. So -pi-halves, and we get to include those, right? To pi-halves. Is that true for cosine? No. What is cosine? 0 to pi. Good. So 0 to pi. All right. And then what about tangent? Picture your tangent inverse function. Picture those y values. Where does it go from? -pi-halves to pi-halves. Do we include these? No, because those are asymptotes. Good. Very good. See, you have this stuff in your brain. We just got to dig it out. Okay, everybody good so far? So let's talk about why we even care about this. Because sometimes we can just calculate it all. But do you know what the sine inverse of -1/3 is? You don't. I don't either. I don't even care what it is, but you don't know what it is, right? So think about this. When we first talked about inverses, I'm not sure that I used this angle with this class because I probably use different angles in every class. But when we first started talking about these inverses, I said, okay, what is the sine of 7pi/6? And it's -1/2, and we could all agree with that, right? So then I said the sine inverse of -1/2 is not 7pi/6. And then I just pushed all of you out of your comfort zone. Like, why not, right? Because the sine inverse, your answers have to fall between -pi-halves and pi-halves. Does that make sense? So this stuff right here is basically what we're doing. I just didn't write it as a composite function. So I'm going to rewrite this exact same thing that I wrote right here, but as a composite function is what we're looking at today. So up here at the top, I want you to write this, that the sine inverse of the sine of 7pi/6 does not equal 7pi/6. Because you see here how it says the sine inverse of the sine of x equals x, but there's an if part to that. So the sine inverse of the sine of this doesn't necessarily equal this. It only does if x falls between -pi-halves and pi-halves, and it doesn't, right? That doesn't mean I don't get an answer. That just means I don't get it. I can't just say, oh, it's 7pi/6. You with me on that so far? So now let's look at number 1, just -1/3. You don't know what the sine inverse of -1/3 is, right? But this -1/3, does it fall in this range right here? It does, right? It falls between -1 and 1. Therefore, I don't have to know what it is. I know then that the sine of the sine inverse of -1/3 is just, what do you think? -1/3. That's it. So then look at the arc cosine of the cosine of pi/4. So pi/4, does that fall within the range that we get to use for arc cosine? Yes, it does. Therefore, what's your answer? Pi/4. Like, you don't even have to know what the values are. You should, but you wouldn't have to here. Does that make sense to you? Now, this can get, because you're already a little confused about the inverses, it can get a little tricky sometimes when you're thinking one thing and it's easy to write down the wrong thing, like write down this ratio when you mean the angle or whatnot. So on 3, 4, 5, and 6, all I want you to do right now is right below the number, I just want you to put an A or an R, meaning that your final answer is either going to be an angle or it's going to be a ratio. Does that make sense? And then there's a mistake on 4. It's the tangent inverse of the tangent inverse. That doesn't make any sense, so we're going to mark that out. So all I want you to do on 3, 4, 5, and 6 is just write an A or an R because your final answer will be an angle or a ratio. What? Yes?
The reason you don't want it to be this is that this is included in the
No, well, we're going to do it.
Okay.
Yeah. But just right now, just do the A and the R, and then we're going to talk about that. Okay, so what do you think about 3? Is it an angle or a ratio? Angle. Okay, what about 4? Ratio. What about 5? Angle. 6? Ratio. Okay, does everybody understand how we know that by looking at it? Ask me a question if you don't, and don't be afraid to ask if you don't know. Because I'm kind of, okay. All right, so now I'm going to look at number 3. I want the arctangent of the tangent of negative pi halves. Does negative pi halves fit into the range we get to use? No, it does not, right? Because we don't include it. So since it doesn't fall in there, okay, and this is why it doesn't work. The tangent, and well, just because it doesn't fall in there doesn't mean it doesn't work at all. Let's think about what we have here. What is the tangent of negative pi halves? Crickets. What is? It's undefined, right? So the tangent of negative pi halves is undefined. So you can't take the arctangent of something that's undefined. Does that make sense? So this is why on this one is actually just does not exist. Okay, so yes to your question. That's not why I had you skip it right then, though. All right, so let's look at number 4. This negative 9 halves, does that fit within the ratio, or I'm sorry, but within the range that you get to use? Yes or no? Okay. It does because this is a ratio one, so it's over here, and it does. It fits between negative infinity and infinity, so the tangent of the tangent inverse of negative 9 halves is negative 9 halves, right? Whatever the angle is, it doesn't even matter at this point. Okay, so look at number 5. The arcsine of the sine of 3 pi fourths, does that fit within that interval? No, it does not. So here's what I want you to write. We're going to write this does not equal 3 pi fourths. Now, that doesn't mean that it doesn't exist, and it doesn't mean I can't get an answer. Just my answer isn't 3 pi fourths. Like, I have to actually do some stuff here. So what we're going to do, and yes, you have to rewrite all this, I want the arcsine of, what is the sine of 3 pi fourths? Square root of 2 over 2. Is it positive or negative? Positive. So I got square root of 2 over 2. So then the arcsine of the square root of 2 over 2 is what? Pi fourths. Good. Because your answers to arcsine have to fall between negative pi halves and pi halves. Are we good so far? Yes? Okay. So let's look at number 6. The cosine of the cosine inverse of 2/5. Does 2/5 fall within that range that we get to use? Yes, it does. Therefore, what's your answer? 2/5. Okay. Everybody good so far? All right. So 7. Is this going to be an angle or a ratio? It's going to be an angle. Okay. And then does 5 pi thirds fit within the range that you get to use? No. But what quadrant is 5 pi thirds in? 5 pi thirds. Oh, good Lord. 4th. 5 pi thirds is in the 4th quadrant because 6 pi thirds is 2 pi, right? So 5 pi thirds, we're in quadrant 4. Are we all good with that? That y'all are worrying me a little bit. Okay. So we're in the 4th quadrant. Well, 4th quadrant really is okay with arcsine, right? The problem is we can't call it 5 pi thirds. So instead, I really have the arcsine of the sine. What could we call this for it to work for arcsine? Negative pi thirds. Good. And so still, I don't even have to know the values, but you should. And your answer is negative pi thirds. Okay. So look at 8. Cosine inverse of the cosine of negative 4 pi thirds. All right, so we know that this is not negative 4 pi thirds because all of your cosine answers, the angles have to be what? Positive in the 1st and 2nd quadrant. So we know it can't be negative. In here, I really should have written does not equal, and I didn't do that. 5 pi thirds. All right, so, but what quadrant is negative 4 pi thirds in? Second. Negative 3 pi thirds would be negative pi, and you go a little bit more in the 2nd quadrant. All right. Do I need to talk it out, or you got it? So here we are, right? It's negative. I have to go this way. Okay, so this is 3 pi thirds. Okay, I think that's why we're... All right, so I got negative 4 pi thirds. I'm in the second quadrant. Second quadrant's okay for cosine inverse, right? But I just can't call it negative 4 pi thirds, so I would have the cosine inverse of the cosine of what would it be in the second quadrant? 2 pi thirds, which means my answer then is just 2 pi thirds. Yes? No? No? Okay, where'd I lose you? Because in negative 4 pi thirds is in the second quadrant. It's like right here. No, it's not right there. Sorry. Oh, yeah, it is. It is. Oh, no, now that I did that, like, no, that's exactly where it is. Come on. Okay, so it's like right here, right? This is how I get all the way to here. That's negative 4 pi thirds, right? But I have to, my angles that I'm using for cosine inverse have to go between 0 and pi, which this lives there, but the coterminal angle, the positive version of that, or one of the positive versions of that, would be 2 pi thirds. Why are you staring at me like I'm crazy? It still doesn't make any sense. Do you understand that 2 pi thirds and negative 4 pi thirds are the same angle? It's like if we run around the track, I run one way and we just meet up, but we're in the same spot. Okay, so when you're doing cosine inverse, your answers have to be between 0 and pi. And like literally between there, the number itself, not just that it lands there. So negative 4 pi thirds is less than 0. It does not fit within this little range of numbers. But this angle does, but in order to make it work, I have to call it 2 pi thirds. Does that make sense? Okay. It's like if your name is Jonathan, but you go by Johnny, it's the same angle, has a different name, but we have to call it by its official name. Does that help? Yes? Maybe? Okay, well, never mind then. Okay, forget about Johnny then. Okay. All right, anything else? Okay. Tangent of the tangent inverse of pi thirds. Does pi thirds fit within that little range we get to use? Yes, so what's my answer? Pi thirds. The arc cosine of the cosine of 3 halves. Does 3 halves fit within that little range that we get to use? Three halves is more than 1, but does this represent an angle or a ratio? If you're going to take the arc cosine in the end, what are you going to get? An angle. This represents an angle. Your angles have to go from negative pi halves to pi halves. Does 1.5 fit in that range? No. What's pi? 3.14159? Is half of that more than 1.5? Yeah, it does fit. This is less than pi halves. 1.5 is less than pi halves. So it totally fits. Do you know, can you tell me what the cosine of 3 halves is? You don't know, right? Because that's an angle that doesn't have a pi symbol on it. Pi's factored in there. But because this does fit in there, it doesn't even matter. My answer is 3 halves. That's not one that you can calculate. Pay attention because, yes, most of your angles have pi on them. That's still in radians, and that is an angle. It just doesn't have the pi symbol there. You good? A couple of those are going to push you out of your comfort zone there. That's why you have to pay attention. That's why I was having you write these, so that you want to, because you want to think about that, especially when you're starting to get confused. Make sure you understand if you're dealing with an angle or a ratio. So look at 11, the arc tangent of the tangent of pi. Does pi fit within that ratio? Or that, I'm sorry, I keep saying ratio, within that range? No, it does not. So I know it doesn't equal pi. The coterminal angle is negative pi. That don't work either. So, but I can work from the inside out. I can take the arc tangent, and see if this will work. What's the tangent of pi? 0. So I want the arc tangent of 0. So what angle gives me a tangent value of 0 that's actually in the range I get to use? 0. So in this case here, this represents a ratio. This represents an angle. The zeros can be confusing too, because you got to make sure you know what part you're talking about. Okay. Ask me a question if you got a question. Brandy, you have a question? You're looking at me like I'm crazy. Where did I lose you? Just because it doesn't. It's just like if it was just factored in. And that's not a mistake either. It's just like that. Like there's a pi value in there. It's just the pi symbol isn't in there. Does that make sense? And it might make more sense if it was a decimal, because then you would feel more like pi's really in there. Like it really is in there. It's just not one of them. Okay. Anything else? Vanessa? You got that look on your face too. Like how I got which one, hon? Number 10 still? Okay. Because in order for my range up here, it has to go from negative pi halves to pi halves, right? So it's from negative pi halves to pi halves, right? So as a decimal, this is 1.5. Can we all agree with that? So this is 3.14159 over 2. So isn't this going to be more than 1.5? That means that 1.5 is like up here somewhere. So this angle is within that range. Does that help? Yes? Did that help a little bit more for everybody else? We're good? Got 2 thumbs up from 80. We're good. Okay. So sine, the inverse of the sine of negative 11 pi sixths. That is definitely not in the range, right? So we know that this is not negative 11 pi sixths. So negative 11 pi sixths, what quadrant is that in? First, right? First quadrant's cool for sine inverse, right? So the sine inverse of the sine, instead of negative 11 pi sixths, pi sixths, good. So then what's our answer here? Pi sixths. Everybody okay with that? Here's the deal with this. It's fine if you know the values and you can calculate them to just work from the inside out, and you will get the same answers if you're doing it correctly. The reason you need to understand that inverse rule is for questions like this where you can't do that, right? When you can't calculate it, you got to know if it's kosher for you to actually use the rule or not. Any questions at this point? You'll like the back better. You may not believe me right now, but I think you will. I know it looks scary. But this here, because they're mixed, this isn't the cosine inverse of the cosine, it's the cosine inverse of the sine. So you don't get to use that rule. So the rule doesn't even matter at this point, because that only works when they match. And it tells you here, work from the inside out. Okay? So we'll do that. Let's take I want the cosine inverse of the sine of pi sixths. So that means I want the cosine inverse of, what is the sine of pi sixths? 1/2, right? Okay, and then the cosine inverse of 1/2 is what? Pi thirds. See how that works? Does your hand trick still work here? Yeah, okay, that's fine. The sine of pi sixths is 1/2, right? And then I want the cosine inverse. Well, this is how I make cosine 1/2 is pi thirds, right? You still use the hand trick, still works. We good? Let's look at arctangent of cosine of 0. So I want the arctangent of, now what is the cosine of 0? 1. Here this is an angle, so it's 1. So then I want the arctangent of 1, what is that? Pi fourths. And if you still struggle with going, oh, I'll put pi thirds. If you still struggle with going forwards with your unit circle, then you're really going to struggle with this. I don't know. I've been preaching since December. So, all right, let's look at 15. The sine inverse of the tangent of negative pi fourths. So that means I want the sine inverse of, what is the tangent of negative pi fourths? -1. Good. So then the sine inverse of -1, like what angle gives me a sine value of -1? What? Negative pi over 2. It's a -1. Yeah, so I'm down here. Okay, you got it? Everybody good? Awesome. 16. Arc sine of the cosine of 5 pi 6. So I want the arc sine of, so what's the cosine of 5 pi 6? Negative, because that's in the second quadrant, so it is negative square root of 3 over 2. So then the arc sine is going to be what? Good, I heard that. Negative pi thirds. Yes? Okay, you work on 17 and 18 and stop. See if you can get those 2 done. Oh, and on 18 it says arctangent inverse. That makes no sense. Just make it arctangent. Oh. All right, somebody that hasn't answered a whole lot out loud, help me with number 17. Be brave. Go ahead. So I want the cosine inverse of the tangent of pi fourths. So I want the cosine inverse of what? Yes, so what is the tangent of pi over 4? 1. Okay, so then I want the cosine inverse of 1, and what is that? Okay, so what we're looking for then is, I want what angle gives me a cosine value of 1? Yes, good. All right, any questions about that one? All right, now Ariane gets to pick the next person that's going to help me. I tried the second period. I've never done this before. It's awesome. Look at him. He's ready. Ricky. All right. So I want the arctangent of the sine of negative pi halves. So that means I really want the arctangent of what? So what's the sine value of, do you know where negative pi halves is on your unit circle? It's the bottom because it's negative. Bottom, it's okay. It's on the bottom. So in the sine, your x or your y? Okay, so what's your y value there? There you go. All right, so then I want the arctangent of negative 1. So what angle gives me a tangent value of negative 1? Okay, negative pi fourths. Good job. All right, then we're going to do 2 more, and then Ricky's going to get to pick somebody. So be ready. All right, so now these last 4 are kind of the opposite of these first 6. So now I want the cosine of the sine inverse of 1/2. So that means I want the cosine of, so what is the sine inverse of 1/2? Pi 6. So then I want the cosine of pi 6, and that's what? Square root of 3 over 2. Good. All right, so sine of the arctangent of 1. So I really want the sine of, what's the arctangent of 1? Pi over 4, which means that that gives me what? Very, very good. Okay. All right, I'm going to give you a minute to work on the next 2. Let me know if you got questions. All right, Ricky, pick somebody for 21. Manuel, 21. You've been chosen. So I want the sine of the arc cosine of 0. So what is the arc cosine of 0? Put negative pi halves. Okay, so negative pi halves does give me a cosine value of 0. However, when I do arc cosine, what am I restricted to? Yes, so we have to be positive. Good. Good. Then I want the sine of pi halves, so what is that? Positive pi halves, because it's positive now. Remember, we changed it. So it's 1, yeah. It's probably negative like originally when you did it because you had the other one, but yeah, it's 1. Okay, we good? Does that make sense, Manuel? You good? All right. Now you get to choose somebody for 22. All right. Jos. So I want the tangent inverse, I want the cosine of the tangent inverse of the square root of 3. So what's the tangent inverse of the square root of 3? Pi over 3, okay. And then I want the cosine of pi thirds, and what do I get? Square root of 3 over 2. Y'all agree with that? No? All right, Manuel, you have to help him out since you chose him. Cosine of pi thirds, they don't agree with this square root of 3 over 2. What is it? Huh? 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 Don't whisper to him. What's the cosine of pi thirds? This is pi thirds. 1/2. Okay, it's 1/2. That makes sense? You have to be sure, you have to be confident. Do you understand why it's 1/2? Okay, good. All right. Any questions at this point? All right. Those were better than the front, right? You liked them better. I knew you would. Now let's look at 23 and 24, because if you look at this, I want the tangent of the cosine inverse of 8 over 17. Do you know what the cosine inverse of 8 over 17 is? No, neither do I. It doesn't matter. It says, let the inside equal theta, determine which quadrant theta must lie. That's the key here. If I'm doing cosine inverse, I am restricted to the first and the second quadrant, right? This is the cosine inverse of 8 over 17. That's positive, so what quadrant am I in? 1 or 2, if I'm taking the inverse of this. 1. So it's going to be over here. I draw my triangle. Then I have to label it with the 8 and the 17. Where does the 8 go? On the x-axis. Where does the 17 go? On the hypotenuse, right? Your right triangle trig. Welcome to geometry. And then, in order to find the tangent of this, I want the tangent of theta. That's opposite over adjacent, so I need the opposite side. How am I going to find it? 7th grade, what is it called? Pythagorean theorem. There we go. Knock it out. Let me see it. Find that side. Yeah, 7th grade, dude. Maybe 6th. Like, no lie. It's old stuff. This pre-algebra. Yeah, long time ago. Just do it. It doesn't matter. And yes, you have to know what 17 squared is. See, I haven't been lying. You have to know your perfect squares up to 25 or you're wasting time. Because you should have been done with this Pythagorean theorem like days ago already. You think I'm being funny. You ain't got time to waste on this. What's 17 squared? 289. You subtract 64, what do you get? 225, so what's the side length? 15. That's a Pythagorean triple that you most likely don't know, and it's okay because you should be able to knock out Pythagorean theorem quickly, way quicker than most of you just tried to do, and most of you didn't even finish. So the tangent of theta is what over what at this point? What numbers am I using? 15 over 8. Okay. There you go. We did something similar to this when we started the trig stuff, and the question I got after everybody started was, how do I know when to use this? Well, it's when you can't calculate this, then you have to, right? You got to draw it out. So draw it out. You work on 24 while I hand out the homework. Yes, you're doing 24 by yourself.
I don't know if it's 2 or 4.
Okay. So the arctangent is negative. For arctangent, you are restricted to quadrants 1 and 2. I'm sorry, 1 and 4. I'm saying 1 and 2 and pointing at 1 and 4. I'm sorry. 1 and 4. So since it's negative, we are in the 4th quadrant. Yeah, I know. Wrong numbers came out of my mouth. So arctangent, because if you don't put it in the right quadrant, you're not going to get your signs in the correct place, right? So negative 12 and 5. This is a Pythagorean triple that you're more likely to know, or maybe you want to actually learn 5, 12, 13. That's right. If not, you got to be able to knock out Pythagorean theorem quickly. Because if you don't know them, it's not the end of the world. These should be easy enough numbers that you can zip through the Pythagorean theorem. You have no time to stumble through that stuff. So then the sine of theta is negative 12 over 13. Questions? Any questions at all? This isn't that bad, but you got to keep your mind on, is this a ratio? Is it an angle? Am I going forwards or backwards? You can do this, but you have to know your unit circle. you have no questions, then put this in your ISN. You have a few minutes. Get started.